Hey guys, all right, so this recording it's for our polar units, okay, in 10.6, and this is for example 3 and 4. Example 3, convert each polar equation to a rectangular equation. So let me just remind you of some of the important equations that we had for conversion. So the first one I'm going to remind you is x squared plus y squared is always r squared, okay? Then the next one I will remind you of x is always r times cosine of theta. And that brings me to y equals r times sine of theta. Well, similarly, since x squared plus y squared equals r squared, I can easily take the square root. So r is also square root of x squared plus y squared. Okay, so these are the 4 equations that you're going to need to know. First things first, r equals 3 divided by 1 minus sine of theta. What you would need to know is we're going to multiply both sides, okay, by, you can think of it as cross multiplication, okay, or if you don't like that, you can think of it as multiplying both sides by the denominator. So if you multiply this by the denominator, you can also multiply this by the denominator, and you should get the same answer whether you cross multiply or multiply by the denominator. So if that's the case, this fraction is gone. So now you have 3 equals r times 1 minus sine of theta. I'm going to distribute my r. So this is going to be r minus r sine of theta equals 3. This is going to give me right here, right? This one, I can totally see what that is. So that is immediately, y. Okay, so r minus y equals 3. So almost there, except I have this problem. I have this r value. Well, r value is going to be square root of x squared plus y squared, and drop down the other values. But instead of dropping it down, what I will do is I'm going to move the y to the right-hand side. The reason is I will have to graph, okay? And because I have to graph, I would need to put this in a standard form of one of the equations that I do know, whether it's a parabola or an ellipse or a hyperbola. But I need to put it in a format that is easy for me to graph, like the standard form. So what is next is I'm going to square both sides, because right now that doesn't look like the standard form. So when I square both sides, this is now what I have, okay? The radical on the left is gone. I'm going to distribute this. So this is 9 plus 6y plus y squared. I will try to combine like terms. Well, you have a y squared on the left and a y squared on the right. That is completely gone. Beautiful, isn't it? So now you have a y squared equals, okay, I will now move, how about let's move the 6y in the front plus 9, like that. I want to put in standard form, so it's easy for me to graph. Standard form means I would need to factor out that 6, so that's going to be 9 over 6, which I will reduce. So x squared equals 6 times y plus 3 over 2, okay? To put it in standard form, I'm going to move the 6 to the other side, okay? So now I have y plus 3 over 2 equal to 1/6 x squared, okay? That is my final equation because that's my standard form. So I know from this is a parabola, okay? Well, if that's a parabola, I can totally go and find, well, it doesn't say graph, does it? Convert each polar equation. Oh, that's it. Woo, I'm done. I got so excited. All right, so I'm done with that. That's my final answer. But let's double check to see if you're right, okay? The reason I want to check is I'm giving this polar, okay? E equals 1, meaning that it's a parabola. Parabola, if I can spell. Okay, well, it's true though, from my polar, I do know that it is E equals 1. So in fact, rectangular or polar, they are both parabola, okay? All right, if you have a hard time catching up, okay, please do pause it and then write. And also go back and listen to it. That's the best thing about having video notes, okay? All right, next, I will now just distribute. So 2 equals 2r minus r cosine of theta. Then I will now go 2 equals 2r minus, this is what? X, okay? Now, I'm gonna try to, okay, multiply both sides, square both sides, but the best thing for me to do is I'm going to move the x to the left. So that means it's 2 plus x equals 2r, okay? Technically, I can go right now, guys, and put in 2 times square root of x squared plus y squared. There's nothing wrong with that at all, nothing, okay? Or you can square both sides, 2 plus x, square both sides, okay? And then replace x squared, okay? So here's the part where a lot of you made quite a bit of mistakes on the last test, is not having quantity around the 2r squared. So when you square it, you had 2r squared only and not 4r squared. So when you're squaring a quantity, make sure it is parentheses is used. So this is 4 plus 4x plus 4 equals 4r squared, okay? So now I can take out, oh my gosh, did I not scale that right? This is x squared is x squared. Oof. I got so excited with the 4's, okay? Equals 4r squared. Now because r squared, it's easy for me to substitute, such as x squared plus y squared, okay? This is, I can go like this, right? X squared plus y squared, like that. Now, what do you do with if you don't square both sides right away? Now you can still do it, but this is just where you do it, like here, okay? There isn't anything wrong with doing it before or after substitution. You can just decide. So I can square both sides there. So guess what? I still have the same exact thing, okay? So multiply that out. This is 4, and the radicals will disappear. Voila, right? They are exactly the same. So now you can choose whichever one you want to work with. Okay, let's put it in standard form. Because this polar equation doesn't look like something that I know right away unless I put in standard form. So let's work out the standard form, okay? I will try to write x squared plus 4x plus 4, distribute my 4x squared plus 4y squared, okay? I'm gonna try to complete the square by combining all x's, okay? So let's go. Move the 4 over, so this is negative 3x squared. Drop down my 4x, okay? Plus a blank space. I will try to complete the square in a little bit. Move the 4y over, so it's minus 4y. So minus 4y squared, okay, equals 2. I'm going to move the positive 4 to the other side. So now that becomes a negative 4. Okay, look, there's a lot of negative signs right there. So what I'm going to do is I'm going to distribute, or not distribute, I'm going to multiply the entire thing by a negative 1. And that's okay, because it's an equation. If it's an equation and you can multiply the right and the left by negative 1, do so. So now I have 3x squared minus 4x plus a blank space plus now 4y squared, okay, equals a positive 4. I can't complete the square unless I factor out this leading coefficient, okay? So take out the leading coefficient plus a blank, then drop everything else down, right? Now, half of 4/3, okay, so half of 4/3, that means it's going to be 4/6. So I'm going to write this down. Half of 4/3, that means I'm going to multiply by half. That's going to be 4/6, okay? Now, so what do you do next after you do half? Can I reduce that though before you square it? Is it okay to reduce? Like 2/3? Now square it, right? Because you have to square it before you go on. So this is 4/9. So 4 9s go here, right? That means on this side, you add 4 9s. But that 4 9s is really being multiplied by a 3. Okay, so this gets 3 times x minus, okay? This is the part where like wherever the halves was is where you're going to put it in. So it's going to be reduced at 2/3. Square that. Drop down your 4y squared equals, let's see, common denominator. Actually, I can reduce this. Let's see, 3 going to 9. That's going to give me 3 here and 1 here. So that's just going to give me what? 4 plus 4, that's just 8, right? So just 8. Okay, let me double check that really quickly. Wait, no, not 8, sorry, common denominator, duh. Okay, so this becomes a 3, so that's really a 12. There you go. So 12 over 3 plus 4 over 3 is 16 over 3. So there you go. Sorry, that was not 8. I got too excited with whole number and then I just ignored the denominator altogether. So now I need to make sure this equals to 1. Okay, so what does that mean? That means I need to divide each and every term by 16 over 3. But dividing by 16 over 3 is the same thing as multiplying by its reciprocal, which is 3 over 16. Okay, so multiply by 3 over 16. Multiply by 3 over 16, okay? So here's what you have. You're right, this is now, if you can see this, this is gonna be 9 on the top, which is 9 is pretty, okay? So 9 on the top, x minus 2 over 3 squared, 16 on the bottom, okay? It's still not standard form, but don't worry, we'll get there. So this is 3 on the top, 16 on the bottom, and this is really 4y squared. And yes, we can totally distribute that soon, but give me a second to fill that out. Okay, remember, not all of us can jump ship so quickly. Okay, so here, from here, I'm going to go up here. I now have 9x minus 2/3 squared over 16. I would try to multiply that out. That's really 12y squared over 16. Equals to 1. So it equals 1. At least I'm there. Now to get rid of 9, you're going to multiply by 1/9. What you multiply to the top, you multiply to the bottom. To get rid of 12, you multiply by 1/12. Yes, you will reduce. Okay, you can reduce now, reduce later. It's not important. Okay, here's my standard form. All right, x minus 2/3 squared. 16 over 9, that's as far as I'm going to go. I can't reduce it. Okay, then drop this down. This is now y squared. 16 over 12, I can divide both top and bottom by 4, so that's really 4 over 3, and then I can have it equal to 1. So this is my final answer, okay? So this looks like it is an ellipse. It doesn't ask, but I might as well write it down. So this is not the only way that you can work this out, okay? There's a lot of basic math that you can obviously do differently. But that's just the way that I lecture it, so that way all the students can see one step to another, okay? If you have a different way, you're more than welcome to show your different way as long as you write it all out, and then I can read it from where it starts and where it ends. Example 4. You are now working on find a polar equation of the conic. It has a focus at the pole, okay? So you are provided with E equals 2/3. The directrix is parallel to the polar axis 3 units above the pole. Okay, because this states 3 units above the pole, I know P. Okay, P equals 3. I have E. E is 2/3. Okay, so this is 3 units above the pole, so you only have one choice in terms of your standard equation. You have R equals E times P all over 1. Because it is above the pole, it's going to be an addition of E times sine of theta. Okay, so I know E. I can fill in E, so R equals E is 2/3. P is 3, so fill in P. Okay, now I'm going to divide 1 plus 2/3 sine of theta. Now when you're writing this, you probably can't have fraction over fraction, okay? So we will try to minimize fractions over fractions. So when I multiply this, you can see on the top the 3's can reduce, okay? So this is going to give me a 2 on the top. Then this is still going to be a 1 plus 2 over 3 times sine of theta. But you can't have a fraction over fraction, so just kind of go the opposite direction of clearing out. We're going to multiply every single thing by 3, right? Because I want to clear this fraction. What you multiply to the bottom, you have to multiply to the top. So your final equation is r equals 6 on the top divided by 1 plus, not 1, I need to multiply by 3, so my bad, that's 3 plus, when I multiply these out, the denominators are canceled, so that's the whole point of multiplying by 3. So sine of theta. So this is your final polar equation, okay? And I'm going to spell this out. You must get rid of fractions over fractions, okay? So if you have fractions over fractions, please clean it up. All right? All right, guys, that's the end of 10.6.